Start with the name of Allah, who is the most beneficent and merciful. I am Hassan Azam and my groupmate Saida Kashalisha. Our final year project is machine learning based automatic COVID-19 detection using lungs scan. We have made this project under the supervision of Dr. Safir Haider, who is the expert of digital system designs and neural networks. This will be the flow of my presentation. First of all, I will be introducing my project, then problem statement, proposed solution, objective, literature review, methodology, dataset, and in results I will be talking about my findings. In finding 1, I will be telling you about binary and multi-class classification of COVID images, neutral images, and pneumonia images. In finding 2, conventional machine learning algorithms such as naive Bayes KNN, and in finding 3 there would be transfer learning, finding 4 wavelet transform, and finding 5 Glahe. According to the World Health Organization, the coronavirus pandemic is putting healthcare systems across the world under increasing pressure. COVID-19, the illness caused by the severe acute respiratory syndrome coronavirus, enters our body through the mucous membranes of our face, such as our nose, mouth, and eyes, by latching its surface proteins to receptors on healthy cells. Gradually, the virus spreads down the respiratory tract, which can cause patients' lungs to become inflamed and lead to difficulty in breathing. So, our project is based on idea of developing a AI machine learning model which detects the coronavirus. The problem was that the conventional COVID-19 diagnosis was time taking, and PCR machines are rare and not available everywhere, and high price and accuracy also varies. The sensitivity of PCR testing is highly variable and have not been reported in a clear and consistent manner to date. Its cost of test is high. To detect the infected patients only early enough and put them under special care, the testing will test them through machine learning. That is very cost effective and saves times. Our main objective is to design or make a machine learning model which detects the COVID-19, and our secondary objective is to reduce the high dimension data set.
Literature review. A research paper which named is Deep COVID Predicting COVID-19 from Chest X-ray Images Using Deep Transfer Learning. It is published in July 2020 in Elsevier, and they have used transfer learning models such as ResNet 18, ResNet 50, SqueezeNet, and DanceNet, and they have taken the data set from this link, this website, and the number of COVID-19 images is 84 for training set and 100 for testing set, means 184 total images for COVID-19. And normal and non-COVID images are 5k images. They have short number of COVID images. Another paper which published in Nature Research, COVID-19, a tailored deep convolutional neural network designed for detecting of COVID-19 cases from chest X-ray images. It is published in 2020 November, and they have used their own model from the scratch, and this is the architecture of their model, and they have named it as COVID-19. They have collected the images, around 14,000 images, and after training their model, they have compared their model with the ResNet 50 and VGG 19. Their sensitivity rate in in this table, the VGG19 shows the 98 for normal, and the maximum sensitivity for non-COVID COVID-19 shows the highest 94, and COVID-19 also shows the highest 91%. Same here, and they have compared with positive predictive value, and the maximum shows their web model 95, 90.5, 90.3, and 90.8. This is the distribution of their data set, and they are also telling that the PCR is time taking, and its accuracy is quite variable. Another research paper, a deep learning approach for COVID-19 and viral pneumonia screening with X-ray images. It is published in December 2020, and they have used their own model. They have created from scratch, and their model consists of 5 convolutional layers, and the total image consists their data set consists almost around 14,000 images, and the COVID images are 289 images. It's very few, and they have taken their data set from these two links, and their accuracy is 90.464%. In this paper, automated detection of COVID-19 cases using deep neural networks with X-ray images, published in April 2020 in Elsevier. They have made their own architecture, and they have named it Dark COVID-19 architecture. Their dataset contains 3 classes: no finding, pneumonia, and COVID-19. We see that COVID-19 images are still smaller in the size, and the total data set contains 1127 images. And accuracy and sensitivity of PCR, they have reported that it's between 60 to 70, and their model is available here, and the data set they have taken from this website. Our methodology is, first of all, we will prepare the data set, and we will divide in the 3 sections: first in the training set, second in the validation set, and the third in the testing set. And the next step, we will label the data set, whether it is healthy, it's COVID-19, or it is viral pneumonia or pneumonia. And in the third step, in the pre-processing step, we will be applying normalization, filtering, augmentation, and the pre-processing step, and also wavelet transform. At the fourth step, we will train and test conventional classifiers, just like a SVM, KNN, perceptron, and CNN, just for comparison purpose. And in the fifth step, we will build the proposed deep learning network, deep learning model, and after that we will train our proposed model, and in the last we will perform the evaluation comparison, and we will evaluate the performance of the proposed model with the others, and in terms of accuracy, precision, recall, and IOC and ROC score. The data set we have collected from these 2 websites that were reported in the research papers, most of the research papers. We have trained our model on binary class data set, which contains normal and COVID-19. The total images are 3000 images, and we have built another data set which contains 3 classes: COVID, normal, and pneumonia. And this dataset contains 4,349 images. After analyzing the data set that we have downloaded from the websites, we saw that the images contains this kind of arrows and the letters, and this can cause problem to train the data set and train the model, and we have tried to reduce as much as we can, and we have come through some solutions with that, and we have removed this kind of arrows to avoid any underfitting or overfitting or and something like that, or any issues coming in the training of the model. That's the flow chart. First of all, we will be giving the X-ray images as an input, and then we will resize that image definitely contain images are with different sizes, and we have to make them in a single size, so we have to resize the image. After that, apply the normalization and labeling the image, and after that we have dataset splitting, and we have split 80% to the training set and 20% to the testing set. After that, we have made the proposed model, the CNN model, and after training that model, we have evaluated the model, and after the evaluation, what we are going to do, we are just calculate the F1 score and other performance is matrices like precision, recall, testing accuracy, specificity, etc. And after that, we will predict and classify the image. We will give the image, and the model will predict that whether it is contain COVID-19 or it's a healthy or it's a viral pneumonia. This is our proposed model. First of all, we have made a model with two convolution layers. There is a convolution layer and there is a convolution layer, and we have tested everything on this two convolution layer, and after that we increased the number of convolution layers in the proposed model, and we did the same things again and again and increased the number of convolution layer to the 4 and then to the 5, and then we saw the results and compared them. So this is the finding one in proposed model with binary data set. This is the data set, and we have trained the data and the model on this data set. The highest percentage of accuracy is coming for F1 score 98, IOC 99, precision 98, and they are 98. We have applied k-fold cross validation. We have gone up to 5 folds, and we have reported total time taken up to 5 folds is 7 hours and 27 minutes. We have trained this model on Google Colab, and the maximum fold accuracy is 99.4, and the average accuracy is 98.7. This is the ROC curve, and this one is the zoomed part on this area. It shows this area of the ROC curve, and this is the precision recall curve. This is the confusion matrix, and this is the accuracy and loss plot. We have used binary cross entropy loss in this function, and the time taken in the training 2 hours 10 minutes, and in the testing 7 seconds and some milliseconds. And then after that, we train same model on multi-class data set, which contains 4,349 images, and it contains COVID, normal, and pneumonia. The maximum or average accuracy it gives are 97.2, the average accuracy, and each class accuracy is reported here, and maximum or average accuracy specificity is 97.88, and F1 score 95.86. This is the ROC curve, and it is zoomed on this area, this part of area, this, and after that this is the precision recall, and that is the confusion matrix, accuracy and loss plot. Here we have used sparse categorical cross entropy for loss function, and we have used the k-fold cross validation up to 5 folds, and the time taken in the cross validation is 3 hours and 36 minutes. The maximum percentage accuracy is 96.58, and the average is 94.89. The training time is 2 hours 10 minutes, and testing time is 7 seconds. And after that we have compared all of the proposed models with each of them, and on the binary data set, and the maximum accuracy which provides is 3 convolution layer, and gives accuracy of 98% and sensitivity 98, and F1 score 96, and AUC 99. We have used image size 256 by 256, and the training time it takes 1 minute. It is because we have reduced image sizes. Previously it was total image size was 3000 for binary, but now the total is 1100 images. Since Google Colab providing 12 GB of RAM, so there were a limitation that if we increase the number of images, the program or Google Colab file were crashing every time after reaching the maximum limit. And we have applied the k-fold cross validation, and we can see here that still 3 convolution model is giving the best results in the k-fold cross validation. And in finding 2 we have applied different classifiers like conventional machine learning classifiers with PCA, principal component analysis, and we have used binary data set here, and we have used almost 14 different conventional machine learning classifiers, which includes nearest neighbors, linear SVM, polynomial SVM, RBF SVM, Gaussian process, and so on. So the maximum accuracy score is 97%, which is k nearest neighbor here is performing well, and the recall, the maximum recall is polynomial SVM and RBF SVM. It's 1. We have kept same number of images like in previous model. And finding 3, we have used the transfer learning with these 4 models, LXNet, RaceNet 50, DanceNet, and VGG16. And here we have applied the wavelet transform, and these results are without wavelet transform, and these results are with wavelet transform. We have kept the number of images same, and to keep just for comparison purpose. And here we can see that these 2 models are giving the best accuracies. These 2 models, VGGNet and DanceNet 121 and VGG16. In finding 4, we have applied wavelet transform with our proposed model, and we have 4 proposed models, and still the best accuracy which is given by the three convolutional layers model, which is 99% accuracy, and overall the results are coming very good, and they are very good, and the training images and testing images are same. And if finding 5, we have used Clahe contrast limited adaptive histogram enhancement. It is used in pre-processing step. What it does, it enhances the image with respect to their contrast. Like if we see this image, it's a before image, and if we see this image is the after image. This is the more dump, and this is more clear, and same goes with this. And we can see this is before, this is after, this is before, and this is after. We can see there is a change between these images, and we have applied this Clahe with transfer learning first. These results are only Clahe. We haven't used any wavelet transform with them. So with Clahe, these 2 models are performing and giving the best results, and Clahe plus wavelet transform, still these 2 models. Overall the accuracy is very good, and precision, specificity, F1 score overall is very good, and these all models are performing very good. Let's talk about the limitations. The limitation is that we don't have the resources so that we can train our model with larger data set. So the limitation is if we are keeping this image size, and we don't have resources to increase number to train images more than 2000, and if we're keeping this image size 150 by 150, we cannot increase number of images more than 4000. And the third limitation is if we increase the data set, we need to decrease the image size, and that is of course not recommended. And the fourth limitation is increase the number of images with higher image size requires more RAM and a good GPU. And what about the clinical perspective? We see that these models, conventional classifier, transfer learning, and proposed model, they are giving best accuracies. They are performing very well. But why still we cannot use these models into the hospitals, and what's the reason behind that? The reason is that deep learning models are often trained on data sets with discriminatory biases, with demographic characteristics such as sex and ethnicity. Like if we are training our model on a specific area, like I'm training my data set on the images of USA. Let's say the images are taken from the USA hospitals, and I'm training my model on that images, and after that I'm giving a test image of that model to that model of another country, like I'm giving test image from China. So what it does, the Chinese people, they have different body structure, their genetics are different, and COVID affects differently on them. Everyone has different immune system, and everyone gets COVID-19 differently. So that's the big reason that we cannot use the model in hospitals, because it's not widely trained. It's trained on just a limited number of images. So it is highly recommended that the training data shall be representative of all the target population, and that's the solution. If we go for the larger data, and then we can say that we can use this model into the hospitals.
Let's talk about conclusion and future work. The conclusion is that our proposed model produces an accuracy of 98.67% and sensitivity of 98.49% and specificity of 98.51% and precision of 98.79%. In future work, we can develop a mobile application for easier usage, which makes COVID-19 prediction more effective. This is our poster for our project. We have described all our project here in this poster. This is abstract, problem statement, introduction. We have talked about our datasets and codes, and we have shown some images here. Our project methodology is defined, and we have concluded it here. This is the barcode. Thank you very much.
And these are the research papers we have gone through with them, references. Thank you so much.